Hello, Math 109 students. Section 3.2 is about the graph of a function. We began to introduce functions, learned a lot of things about functions in 3.1. 3.2 is focused on a particular way to demonstrate a function or to display a function, that is with a graph. It's not the only way, but it's certainly an important way. Remember that we said a function, what makes a function stand out is that it is perfectly predictable according to input. If you know the input, there's no question or doubt about what the output is. It is only one possibility for the output. Every input has exactly one output. So how does that relate to a graph? How can we look at a graph and sense whether that graph is the graph of a function or not? Well, if the horizontal axis, here's the input axis, all right? Here's the input axis right here. And here's the vertical axis is the output axis right here. Let's just pick any input. Let's say this input right here. The question is, for that input on this curve, how many outputs are there? Okay. Here is there's one single point associated with that input, and therefore there's only one output associated with that input right there. Is that the case for every point we come across along this horizontal axis? If I pick one way over here, it's going to go up and we're going to hit the graph somewhere right in here, right? And therefore there will only be one output associated with that input right there. And that's going to be true for every single output, every single input on that graph. Now look at part C. Pick an input on part C. Let's say we pick this one. How many points are there on the curve associated with this input? Well, we have one there, and we have one there. So there are two different outputs associated with that input. Therefore, it's not the graph of a function. Now, there's a very simple way to explain this. It's called the vertical line test. And the vertical line test would say, if you were to draw a vertical line everywhere on this thing, like put a vertical line anywhere on this graph, if any vertical line you can draw would only cross that curve in only one place, then it is a graph of a function. However, if there are any vertical lines that you could draw that would touch the function in more than one place, then it is not a function. If that would touch the graph in more than one place, it's not a function. So look at part B and apply the vertical line test to part B. Is it a function or not? It is a function because every vertical line you can draw would only touch that function in one place. What about part D? That's a function, that's a function, that's not a function. What about part D? It's not a function either because the vertical lines you draw are going to hit the graph in more than one place. Not a function. Our next example is an example about looking at the graph of a function and obtaining information about the function from that graph. Okay, this that says this is the graph of a pendulum, like a grandfather clock, pendulum bob, and it's the graph of the distance that bob is from its resting point, from its equilibrium point at time, over time, or at some time x. So y is the distance that bob is from its equilibrium point, where it would be if it was at rest, and x is the time that passes by. All right. Now let's just do part A and do the rest of them. Part A. All right, f of 0. The 0 is the input. That's the x. So we look on the input axis, the horizontal or x-axis, where the horizontal axis has a value of 0. That would be here, right here. And we look on the curve and we see the point on the curve right there. We say that the value of the function, when x is 0, the value of the function at 0 is the y value. It is 4. All right. F of 3 pi over 2 means that we look on the x-axis and we find where the x-axis has the value of 3 pi over 2. And there's 3 pi over 2 right there. So here it is. What is the value of the function right there? The y value is 0. F of 3 pi. 3 pi, where's 3 pi on this axis? Well, there's 3 pi, it's right here. Here is where 3 pi is, and this is the point that has 3 pi as its x value. What is the value of the function? In other words, the y value, it is -4. All right, part B. What is the domain of f? Remember that domain means all of the x values that are represented in that function. All of the inputs, or x values. So looking at this horizontal axis, the question is, what all values are represented in this blue curve associated with any value on this x-axis? All right, what about 0? Is 0 represented? Yep, there it is. What about pi over 2? Yep, there it is. But what about anything between 0 and pi over 2? What about all these little values right here? Yep, all those little values have points also. They all have these points. So where does it stop? It continues to have all these values are represented in that blue curve until we get to here. Once we get past here, that's the last point to the right that we have in that blue curve. Notice that the blue curve ends in points, not in arrows, right? If it did like that, we would assume that it keeps going forever. And if it did like that on the end, we'd assume that it keeps going forever, but it doesn't. It ends in points, right? It ends in a point like this, not an arrow. So we assume that it stops at that point. So the domain for this function would go all the way from 0 on the x-axis all the way to 7 pi over 2 on the x-axis. Okay? So that's our domain. Our domain is from 0 to pi over 2. Would those two values be included? They would, because they have closed circles. They have filled in dots at those values, meaning that it actually hits that value. If those dots were open circles, if it came to a point if it came to a point like this, you would know that that number would not be included. But when it comes to a point like this, and the dot is a filled in dot, then it is included. All right, part C, the range. The range is the y values. What all y values are represented in this function along this y-axis? What about -5 or -100? No. When does it begin? What's the lowest point that on the y-axis that the blue curve begins to have those values included? -4. -4 is the lowest point where those values are included. All right. What about -3 and -2? Yeah. -3 and -2 and -1 and everything between -3, -2, and -1. All those points have values represented somewhere, at least one place in this blue curve. When does it stop having values? At 4. There's nothing above 4 that is represented in that blue curve. So it goes from what to what then on the y-axis? From -4 to 4. And once again, these points, these lowest points and these highest points, they are filled in circles. They're not open circles, so they are included. So we put brackets around them. All right. Next, it says list the intercepts. All right, part D, the intercepts. The intercepts is anywhere that it crosses or touches and the X or the Y axis. Since it says intercepts, since it doesn't just say X-intercepts or Y-intercepts, it just says intercepts, we actually have to give the ordered pairs for those guys. If it just said X-intercepts, I could just give the X values where it hits the X axis. But since it says X-intercepts, since it just says intercepts, I do have to give the ordered pairs. So the Y-intercept would be 0, 4. The X-intercepts would be, I'd have multiple ones. I'd have pi over 2, 0. 3 pi over 2, 0. 5 pi over 2, 0. And 7 pi over 2, 0. Those are my all my intercepts. Part E. How many times does the line y equals 2 intersect the graph? The line y equals 2, first you need to know that that is a horizontal line that crosses the y-axis at 2. It always has a y value of 2 everywhere, so it's a line that runs like that. Now it's easy. How many times does the graph intersect that line? 1, 2, 3, 4 times. Part F. For what values of x does f of x equal negative 4? For what values of x does f of x equal negative 4? Well, when it says f of x, that means y. Y is negative 4. The y value, the vertical value, is negative 4. Where's the vertical value or the y value negative 4? At these 2 points right here. So it says for what values of x is that the case? The x values are pi and 3 pi. Pi and 3 pi. All right. And finally, this is a good question. For what values of x is f of x greater than 0? For what values of x is the value of the function, in other words, the y value, the vertical value, greater than 0? Okay? It's greater than 0 in this whole upper half of the graph here. That is where the y values are greater than 0. All right, so for what values of x is that true? That would be throughout here. So what is that from? That's from what to what? On the x-axis. That's from 0 to pi over 2. So I'm going to write my answer to part F right here. 0 to pi over 2. Now, notice it says greater than 0. Not greater than or equal to 0, but greater than 0. Well, right here, the function value is definitely greater than 0, so I'm going to include that x value right there, 0. But right here, it's equal to 0, not greater than 0, so I'm not going to include pi over 2. If this had said greater than or equal to 0, I would have put a bracket on the pi over 2 as well. All right, union, where else? Well, not here, but again, we are greater than 0 throughout that region there. Where does that go from where to where? From 3 pi over 2 to 5 pi over 2. They're not going to be included because at 3 pi over 2 and 5 over 2, they're actually equal to 0, not greater than 0. So parentheses, 3 pi over 2 to 5 pi over 2, parentheses. And then one more. I'm kind of out of room here. I'm going to write it below it, union, where else? Not here, but here. What is that? That's from 7 pi over 2 to 4 pi. All right. that is from parentheses 7 pi over 2, 7 pi over 2. I'm not including the 7 pi over 2 because it's equal to 0 there, but the 4 pi is greater than 0 here, so I'm going to include the 4 pi. All right. I'm looking back at my answers now that I gave you, and I'm looking back at part B, and I'm thinking that what I said there might have been wrong. I don't really remember what I said there, but I'm going to go back and hit that again because it looks like I didn't write the right answer. Not sure if I said the right thing and wrote the wrong thing down, or if I just completely miffed it, but let's try that again. The domain, again, goes from here, like all the way to here. So the domain is all those x values right there. So what does that go from what to what? The domain is from 0 to here. What is that? 4 pi. 0 to 4 pi. And that's going to be with brackets because both of those have closed circles that are included in the domain. I don't know what I wrote right here. I can't even remember, but that's what the domain actually is. All right. All right. The next example, it says consider the function, and it gives us an equation. And it tells us to find the domain of f. It's possible that we could graph this in our graphing calculator and try to determine a lot of things about the graph from that, or we could do things by hand here. Part A, I think it would be easy to do by hand. We've actually done several of these in the previous video. So the domain is all x such that that denominator, x plus 2, cannot equal 0. Therefore, x cannot equal negative 2. So the domain is x does not equal negative 2, meaning x is anything but negative 2. If we did it as an interval, we'd say negative infinity to negative 2 union negative 2 to infinity. And the parentheses mean that the negative 2 is not included. Part B is 1 1/2 on the graph of f. How do we tell? What I would do is I would plug 1 in for x. Plug 1 in for x. 1 over 1 over 1 plus 2 and see if it comes out to be 1/2. Well, this comes out to be 2/3. So 1 1/2 is not on the graph. The point 1 2/3 is on the graph, not 1 1/2. All right, part C, if x equals 2, what is f of x and what point is on the graph of f? All right, so part C, I wish it wouldn't do that. Part C, if x equals 2, that means I'm plugging 2 in for x, 2 plus 1 over 2 plus 2. That gives me 3/4. So if x is 2, f of x is 3/4. And so what point is on the graph? Well, it's the point 2, 3/4. 2 for x, 3/4 for y. Part D. If f of x equals 2, what is x? That means I'm plugging 2 in for f of x, not for x, but for f of x. So 2 goes in the place of the f of x. I see don't have room for D right there. I'm going to come over here and do it. Part D. I'm going to plug 2 in for f of x. And then I'm going to solve for x. So I'm going to, what I would do is I would multiply both sides by x plus 2 to get the x plus 2 off the bottom. It cancels, and over on the left side I multiply, I get 2x plus 4 equals x plus 1. I would move my x over now to get my like terms together. That would give me x plus 4 equals 1, subtract 4, x equals negative 3. So the answer to part D is negative 3 for x. And the second part of part D, what point is on the graph of f? It would be negative 3 for the x and 2 for the f of x. Part E, what are the x-intercepts of the graph and what points are those? So part E, the x-intercepts. The x-intercepts are when it hits the x-axis. And when it hits the x-axis, the y value is always going to be 0. So to find x-intercepts, I just always plug in 0 for y. Or f of x in this case. And I'm solving for x. So once again, I'll get the x plus 2 off the bottom by multiplying both sides by x plus 2. Just to cancel that out. Well, 0 distributed into that is still going to be 0. So 0 equals x plus 1. Subtract 1 and I get x is negative 1. So that is the only x-intercept I have. So what is the ordered pair, or the point that represents? It is the point negative 1 for x and 0 for y, negative 1, 0. All right, I think this is the last example in this section. It's a pretty short section. It gives me an average cost function for manufacturing X computers per day for a particular company. And the average cost function is given this symbol C with a line over the top, or C bar. Average cost for manufacturing X number of computers per day is equal to this function with X in it. So you plug X in there and it tells you the average cost of manufacturing that number of computers. Then it wants us to find the average cost of manufacturing 30 computers in a day, 40, 50 computers in a day. So I reckon I'll just type this in. I will type in 0.56 times 30 squared minus 34.39. So let me change that to a minus 34.39 times 30. Plus 12.57. Plus 20,000 over 30. And we get the answer is 1351.54. Then it wants me to do the same thing for 40. Well, it's pretty easy to type this in. Now that I've typed it in once, I can hit, see this blue thing above enter, it says entry. I can hit second entry and it brings up what I just typed in. And all I got to do is change all the 30s to 40s. Change that to a 40. Change that to a 40. Oops, I only changed 2 out of the 3. I got to change one more. Got to change that to a 40 also. So the answer to that is 1,232.97. All right, so 1351, 1232, and then the last one I'm going to do it again, and I'm going to type in 50. All right, so I typed in 50. So for 30, it was 1351. For 40, it was 1232. And for 50, it was 1293. All right, then it says graph the function for x between 0 and 80. So let me do that. I'm going to go to this calculator, and I'm going to graph this function. I've already typed it in, and I'm going to hit graph. But now I'm going to hit window, and I'm going to change my window from 0 to 80. For 0 on the x, 80 on 0 for the x min, 80 for the x max. The x scale, I can leave it there, or I could make it be something more reasonable. It really doesn't matter. I'm going to make it be 8, but it truly does not really matter. Now, the y min, what is the lowest cost I could possibly have? Well, I guess I could say 0 as the lowest cost I can have. What's the maximum cost that I want to be able to see? Well, we were talking stuff like in the 1300s and 1200s, so I'm going to say 1500 because I know that will get everything that I want to see in there. And I'm going to let my y scale, again, it doesn't matter, but I'm going to change it to 100 just because I'm a little bit obsessive that way. Now I'm going to hit graph and notice the graph that I see. Here is this function. Okay, and I bet I know what it's going to ask me. Let's see. Which value of X minimizes the average cost? It tells me to create a table with table start 1 and delta table equal to 1. I'm not going to do that that way ultimately, but I'll show you at least how to get started on that. You can go to table, go to table set, and it says let the table start be, didn't it say 1? And the delta table 1. So you click 1 for table start 1. Delta table is already 1. Then you can go look at the table, second table. And so I can look at the cost for manufacturing this many computers. I can go all the way down here and look at those like that. But it wants to know the value of X that minimizes the cost. And I can see that sort of right here. And I can see that it's going down from 31 to 32, 33. It's going down, 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 down. Okay, 41, it's still going down. But when I get to 43 and 44, it's going back up. So it looks like around 41. But the way that I would do this instead of a table is I would look at my graph and I would say second calculate. I'm going to calculate the minimum on the graph. That's what I would rather do. So the minimum is like right here somewhere. But this calculator needs you to talk to it a little bit. It says, how far to the left do you want me to look for this minimum? So I'm going to scroll to the left until I know I'm to the left of the minimum. So anywhere in here would work. Then it says right bound. How far to the right do you want me to look? So I'm going to scroll to the right until I know I'm to the right of that minimum. So anywhere in there should work. Then it says guess. I could just hit enter again, or I could go a little closer to where I think the minimum is and hit enter. Then it tells me exactly what the minimum is. The minimum is 41.22. So I guess we can't make a fraction of a computer. So I would say that we should make 41 computers per day on average in order to minimize our average cost. All right. Again, here's a summary of what we learned in section 3.2. Good luck on your 3.2 assignment. I'll see you again in 3.3.